Hi there, 5th grade math students. This is chapter 15.5, finding the volume of a rectangular prism and of a liquid. In order to calculate the volume of a rectangular prism, we first need to know its length, its width, and its height. Let's take a look at this red rectangular prism. The length is 22 centimeters. The width is 8 centimeters, and the height is also 8 centimeters. Let's practice finding the length, width, and height on some other rectangular prisms. Please find the length, width, and height of the two rectangular prisms given here. Press pause while you work. There are two more practice problems on the next page. Now please find the length, width, and height of the two rectangular prisms given in problems 3 and 4. Now let's work to find the volume of a rectangular prism. This rectangular prism is made up of 1 centimeter cubes. There are 20 1 centimeter cubes, so the volume is 20 cubic centimeters. Let's add another layer. By adding another layer, we now have 2 layers of 1 centimeter cubes. Each layer is made of 20 1 centimeter cubes, so there are 40 1 centimeter cubes overall. The volume of B is 40 cubic centimeters. Here's another method for finding the volume of figure B. We can count the number of cubes to see that the length is 5 centimeters, the width is 4, and the height is 2. Now, we simply use multiplication to find the volume. Length times width times height. Length is 5 centimeters, width is 4, height is 2, giving us a total volume of 40 centimeters cubed. Let's find the volume of this cube. A cube is just a rectangular prism in which the length, width, and height are of equal length. So we use the same rule for finding the area. Length times width times height. Our length is 6, our width is 6, and our height is 6. So the volume will be 6 times 6 times 6, which equals 216 centimeters cubed. Use the formula you just learned to find the volume of these two cubes. Press pause while you work. There are two rectangular prisms to calculate volume for on the next page. Use the formula for volume to find the volume of these two rectangular prisms. Press pause while you work, and when you return, we'll learn to find the volume of a liquid. Let's talk about finding volume of a liquid. 1 liter of liquid completely fills a rectangular container that is 10 centimeters long, 10 centimeters wide, and 10 centimeters high. We can find the volume of the cube by taking 10 times 10 times 10, which gives us 1,000 centimeters cubed. Now 1 liter is also equivalent to 1,000 milliliters, so we can set up this equivalent statement. 1,000 milliliters is equal to 1,000 centimeters cubed, or 1 milliliter equals 1 centimeter cubed. Sometimes we also refer to this as cubic centimeters, which can be abbreviated as cc's. Please practice making this conversion on your own. In problems 9 through 12, please convert liters or milliliters to cubic centimeters. And in problems 13 through 16, please write the cubic centimeters as liters and milliliters. Let's use all we've learned about solving for volume to solve some simple one-step word problems where we will calculate capacity, or the maximum volume that a container can hold. This rectangular container shown is completely filled with water. How many liters and milliliters of water are in this container? If it's completely filled or filled to capacity, that means we filled every possible space inside. It's at full volume. So let's simply calculate the volume of this box, and then we'll know how much liquid is in it. First, we need length times width times height, which will be 15 times 10 times 8, which equals 1,200 cubic centimeters. We're asked to give our answer in liters and milliliters. So the first thing I'm going to do is change that cubic centimeters to 1,200 milliliters. There are 1,000 milliliters per liter. So my final answer in simplest form will be 1 liter, 200 milliliters. Use the same technique that we just used together to solve for the capacity of the box shown in liters and milliliters. Now let's solve a two-step problem involving volume. Each edge of the aquarium shown is 15 centimeters long. The aquarium currently contains 1.25 liters of water. How much more water is needed to fill the aquarium completely? The first step I'll want to take is to find the capacity of the aquarium, or the amount of water it could hold if it were full to the very top. That will be calculated by taking length times width times height, or 15 times 15 times 15 centimeters, which equals 3,375 cubic centimeters of water. Remember, cubic centimeters are equivalent to milliliters, so we can rewrite this as 3,375 milliliters, or 3 liters, 375 milliliters. We could also write that as 3.375 mLs, or milliliters. Our question was, how much water do we need to add to fill our aquarium all the way to the top if it currently holds 1.25 liters of water? Now we just have a simple subtraction problem, correct? The maximum capacity is 3.375 liters. It currently holds 1.25 liters. Now we subtract to find the difference. We could add 2.125 liters of water to completely fill the aquarium. Now try solving a similar problem on your own. Problem number 18 walks you through the necessary steps to find out how much more water is needed to fill this container completely. Press pause while you work. We have one final sample and practice problem to wrap up Chapter 15.5. Here's our final problem for Chapter 15.5. The cubic tank on the left is 2/3 full. The water it is in is then poured into the rectangular tank on the right until it is full. How much water is left in the cubical tank? Give your answer in milliliters. Okay, our first step is going to be to figure out the capacity of the cubical tank on the left. Length times width times height will give us the full capacity, which is 21 times 21 times 21, which is equal to 9,261 centimeters cubed. However, that is not the amount of water that's in our tank right now. Remember, the problem told us that the tank is only 2/3 full? So to find the current volume of water in the tank, we need to take 2/3 times 9,261. Right now I'm going to switch over to milliliters because we want our answer in milliliters, not cubic centimeters. So 2/3 of 9,261 equals 6,174 milliliters. Now let's move on to the next step, which is to calculate the capacity of the yellow box. The yellow box has a length of 26 centimeters, a width of 12 centimeters, and a height of 15 centimeters, giving it an overall capacity of 4,600 milliliters. So remember, the problem asked us to pour the water from the cubical tank on the left into the yellow tank on the right. Not all of the water that's currently in the tank is going to fit. So how much will be left over in the cubical tank after we pour out what we can? This is now a simple subtraction problem. Let's take 6,174 milliliters minus 4,680 milliliters to give us 1,494 milliliters. That will remain in the cubical tank after we have poured out as much as we can. And here it is, the final practice problem for chapter 15.5. It's pretty tricky, but I want you to give it your best try. We'll definitely go over it together tomorrow to make sure that you understand how a problem like this works. This is not only the end of chapter 15.5, it is the end of 5th grade math. Congratulations, you finished! I'll see you tomorrow to do this last set of practice problems together, and then we say goodbye to 5th grade math. Have a great night. Thanks for all your hard work, and I will see you tomorrow.